Assalamu alaikum student, welcome to daily physics lecture. Today's lecture is 10. So in the past 3 days we were discussing about Kirchhoff's law. In the previous day we have discussed about multiple loop problem. So today we are going to do multiple loop problem again, but slight weird circuit. So now as this is our circuit, you can see it. This is a very good looking circuit. And these are the steps we are about to follow. We have followed it in the previous day, that means yesterday. Now we will follow those steps again. So now let's see it. It's a very beautiful circuit. Now it has a weird thing. So if I, let's name those points. I will do it later. So when you see something weird like this, then just try to simplify it. So is it possible to simplify this circuit without applying Kirchhoff's law? Look at this circuit. This is very beautiful. This loop contains too many cell and resistance, this middle one also. But here, this last small one, now we can see that these two, that means 8 and 4, these lines don't contain any cell, right? So we can exactly take a combination of resistance here. And 8 and 4, which means here 8 and 4 means 8 plus 4, it is 12. And now this 12 and 4 in parallel, so 1 by 12 plus 1 by 4, if we go for parallel, then the equivalent will become equivalent, okay, 12 and 4 equivalent, 3. So now it makes our weird but good looking circuit simpler circuit. So now we only have 1, 2 and the whole 3 loops. So let's start from the first step, name the points. Let's name it A. Okay, let's choose here a point B. That's our C, D, E, F. So here A, B, D and E, these are not points, these are not junctions, they are just only points, edges. And the C and F, these are junctions. So here we have 3 lines again, C, B, A, F, this is one line, C junction to F junction, C to F, this is another line, and C, D, E, F, this is the third line. So there are 3 lines and the lines are C, B, A, F. This is one line, C, B, A, F. These are lines. C to F, this is the another line, and C, D, E, F. So these are, this is another line. So these are 3 lines. Okay. So we have got 3 lines. And also there will be 3 current. And what are the loops? So here we have 3 loops. This is one loop, C, B, A, F, C. This is one loop, that means the left loop, C, D, E, F, C. This is small one, this is the second loop, and this total loop, that means D, C, B, A, F, E, D. D, C, B, A, F, E, D. That's the third loop. So there are 3 loops, 3 lines, 2 junctions. So it's like the yesterday circuit. So we can use the Kirchhoff's second law thrice. So now we are done with step 1. So let's assume the current flow. That's the assumption. I said that there are 2 assumptions, step 2 and step 3. The first assumption, assume the current flow through lines. We have to go through the lines and assume current flow. So from C to F, so let's assume this is anti-clockwise. And I1, C to F. So this I1 is starting from C, from A till F, this will remain I1. So this is the current through line CBAF. Okay, so through this line, let's assume the current flow is like this. So assume it's I2, this is also I2. So that's I2. The current flow through CDEF, this line. And we have another line in the middle. So I already told you that if you are done with the two assumptions, two current flow, and what about the third, this be permitting. Okay, so now here at point C, this is a junction, I2 is moving outward. Look, this is I2 and this is moving outward, and that's I1, it's also moving outward. So it is better that choose one current which is I3 that will move inward. So inward, outward, it makes sense. But if I assume all inward or all outward, it doesn't make sense. So we have completed step 2. We assume the current flow in all lines. We are done. Okay, I may be right or wrong, doesn't matter, but I assumed it. So now what about the third point? Default positive and negative direction. Okay. So typically, as I always assume the direction, positive direction towards clockwise, it's all about me, okay? I always assume direction clockwise, it's all about me, So clockwise is our positive. So now we are done with 3. Use a junction, okay? Step 4, use a junction. So let's use F. Any one of the following, doesn't matter. Or C, doesn't matter. So at junction F, what is here? I2 is moving in. We know the Kirchhoff's junction law is equals to I in equals to I out. So here in current, I2 is in current, it's moving in towards F. I1 is also moving in. So I2 is moving in, I1 is moving in, and now you can see that I3, this is the arrow, right? So I3 is moving out. So that's I3. So we have got one equation. I2, I1 is equals to I3. So let's write it down. So that's equation 1. So we have got equation 1. Now we need 2 equations to get all current flows. Because if I can get I1, I2, or I2, I3, or I1, I3, I can get the other. Right? So now we need 2 equations. So for that 2 equation, we have to use the step 5, that is Kirchhoff's second law, twice in 2 loops. So now the trick. What was that trick? Is there any line which is resistanceless? So let's try to figure out. C2F, this line, we have resistance here. 1, 2 resistance. So it's resistance, it includes resistance. So it's not resistanceless. So here, C2F, look at this line. This line has resistance. Wow. It doesn't have resistance. From C to F, CF is resistance less. So we have got our resistance wire. So we should be happy. Now whatever, is it resistance less? Let's see it. Oh, we have resistance here. 1, 2. We have 2 resistors here. So C, D, E, F, this line is not, it includes resistance. So as we have a resistance-less line, so we have to choose those 2 loops from 3 loops which will contain this line. So we can choose this left loop, it contains CF, and the right loop, it contains CF2. So we have got 2 loops, left loop and right loop, both contains CF. We are not exactly taking the total loop, okay, the third loop, the large loop. We are not taking that. So we have got our loops and we know which loops to use. So let's use the left loop, and that loop is CBAFC. Okay, so Kirchhoff's second law, summation of E is equals to summation of IR, we know it very well. So let's use the left side, get E's. Forget about IR. So in this loop we have 1, 2, 3, 4. 4 cells, too much. It's too much cell. 1, 2, 3, 4. 1, 2, 3, 4. Okay, 4, 6, 8 and 2. These are the years. Okay, let's start with the 4. There's the positive, there's the negative side. So here the direction of cell is towards positive. So our default direction is clockwise. So this cell is acting towards the opposite direction. So this should be negative. So -4 our first cell. Now what about this 6? Oh, there's a positive, there's the negative side. So this direction. So now this is the direction of the cell. So our default direction is clockwise. So this cell is again negative because it's acting opposite directions. Our default direction is clockwise and this cell acting towards the opposite direction. So this 6 volt is minus again, very upsetting. So now what about this 8? The plus, minus. What about this 8? So 8 is acting towards this direction, right? So for 8 volt, this cell, our default direction is clockwise and this cell is acting towards the other direction. So 8 is also negative. I am getting too many negative cells. Now what about this 2? There's a positive, there's a negative. Yes. Now I got the last cell which is acting towards this direction, right? 2 volt. The last cell is acting towards this direction, towards the positive side. So our default direction is positive, clockwise. Our default is clockwise and it is acting clockwise, right? So this 2 is the positive cell. That's the only positive cell now. And now let's go for the right side. Summation of IR. How many resistance we have in this loop? No resistance, 1 resistance, 2 resistance, and we have 3 resistance, the internal one. Okay, now that's the most interesting thing, that this loop contains one cell which has the internal resistance. Internal resistance is also a resistance, right? So you have to take this resistance. Okay? Okay, so there are basically 1, 2 and 3. 3 resistors, not 2. 2 is visible and 1 is internal, so total 3. Okay, so there should be 3 currents. So now, okay, through this 10, the current flow is I1, so it's 10 I1. So let's assume it's positive or negative. That's the direction of current. You can see this I1 is acting towards this direction from this arrow. Our default positive direction is clockwise, right? And these 10 I1 through 10 is acting towards the opposite direction. So that's minus 10 I1. Okay, no problem. So what about this I2? This is the current flow. The current is flowing towards this direction and our default positive is clockwise, right? So this I1 through 2 is also negative. So plus 2 I1, this is another negative, right? And we have this 2 ohm again. So now this 2 ohm is inside of the cell and obviously the current I1 is moving through this 2 ohm too, right? So 2 I1 is also moving through 2 and it's acting towards this direction. So through this internal 2 ohm, the current, our default positive is clockwise and current is moving towards the other direction. So this 2 is the resistance, I1 is the current flow and it is also negative. So we have 3 current flows through 3 resistors, 2 visible, 1 internal and all are negative. It's very upsetting. So now let's simplify. At the left side we got 4, 6, 8, 10 and minus 6, minus 16. And at the right side 10, 2, 2, minus 14, I1. So I1 is equals to, although all are minus, but I am getting a positive value of I1. And I1 is equals to, it's 8 by 7. So I have got I1 and it is positive 8 by 7. Both sides negative, so it's the value getting positive. So that means though I have taken the default positive direction clockwise, so all the value is negative despite I have taken the right direction of eyes. That means our second step assumption was right. Okay. The third step assumption clockwise may be wrong, doesn't matter, but this current flow's direction which I assumed at the second step was right. So that's why I am getting the positive value of I1. So now we have got I1. Let's deal with the another loop. Okay, what is the value of this loop? This loop is C, D, E, F, C. Okay, this loop use Kirchhoff's second law, summation of E is equals to summation of IR. So how many cells are here? There are too many cells. Oh my god. 1, 2, 3. There are 3 cells. Okay, so let's start with this 12 plus minus. So it's getting towards this direction. So the direction of this 12 volt is like this. Default positive is clockwise, and fortunately this 12 is acting towards this direction, which is the same direction as my default clockwise direction. So this 12 volt is a positive cell plus. We have this 8 and 2. 8 is acting towards this direction, and 8. For this 8, this is a positive negative is towards this direction, and that's how my default clockwise direction. And now 8 is acting along clockwise for this loop. So 8 is also positive. And now what about this 2? 2 is acting towards this direction, right? So now for this 2, look at this. 2 is now, let me go to this direction. So that's our clockwise direction, right? So 2 is not acting clockwise, it is anti-clockwise, so opposite direction. So 2 is now, 8 is positive, sorry, but 2 is negative. So we are done with the left side. And what about the right side? The current flow through resistances. There are 1, 2, 2 resistance, and the current flow is I2. So through this 3, the current flow is I2, and this is this direction. So default positive is clockwise. So I2 is clockwise. So 3I2, this is positive. Now we have another resistance 3, and the current flow is I2. So another 3I2, and this is acting towards this direction, and this is also towards the same direction as our default clockwise. So this is also positive. So here we have 3 cells, 12, 8 and minus 2. 2 are positive and 1 is negative. So if you simplify, we get here plus 18, and at the right side 3, 3, that is plus 6I2. So we have got the value of I2, and it's positive 3. So we know I2, we can get I3. So if this is our circuit, and we have to get the current flow, we can easily get the current flow by using Kirchhoff's law. So I will give you a homework again. So please start this circuit well and the circuit in the previous lecture. Next day we will solve some different kinds of slight tough, because in the next day I will not give any resistance-less line. So that time we will be able to see how we can solve this resistance-less line. So please try to understand this, and if you can't, then please comment me through the comment box. Let me know what are your problems, and please remain in your home, stay safe, do not move outside. And this is for today, and all the best. All of us, thank you. See you tomorrow. Bye.